Okay, I'm going to have a few videos about variability. First one will be just what variability is in general and why it matters. The second one's going to be about the range. The third one about interquartile range. The fourth one about population variance and standard deviation. And then the fourth one will be very similar to number 3, sample variance and standard deviation. So this first one is really about just trying to figure out what's going on with variability. Now, variability is really just the extent to which things fluctuate or change, really asking the question of how are things different? What's the range of possibilities? Is every day the same, or are there really high highs and really low lows? Or maybe I just have a bunch of really high highs and no low lows, right? And I can think of a practical application of this is when you're looking at the kind of employment that you want. People who are very kind of risk-seeking don't mind some kind of salary schedule that looks like something like this. I have a friend who was a used car salesman for a while, and on a good month, he would make about $12,000. That happened, I think, like once. Most months, though, he would be much lower, somewhere between 500 and 5,000. And those months where things got really slow, right? It was really hard to make ends meet, especially when you have a wife and 2 kids. She's working too, which provides a little more stability. But this type of variation in how much you take home each month can be pretty unnerving and really hard to plan. Now, if I look at this, right, what this represents is making about $36,000 a year. Now, you can either get paid $3,000 a year, which makes budgeting and planning a lot easier, or you can kind of roll the dice and know that you have the potential to make a lot, but you might also have a lot of months where you make very little, and that can be stressful. Another example of this is in happiness or mood swings, right? If we look at this middle line here is kind of the baseline of not good nor bad, just kind of average. Most people function around this red line here. You kind of go between a 3 and a 4, 2 and 3 on a day-to-day basis of happiness. And some days are really good, some days are really bad. But usually you're staying right in here. Now, some people's baseline's a little higher, like this green line, where you're kind of happy all the time. And then other people have kind of a lower baseline or kind of average experience where things fluctuate, but it's always kind of negative. When you think of bipolar people, and I'm sure some of you have either have experienced this or know somebody who goes through this, there are incredibly high highs followed by really, really low lows, followed by incredibly high highs, followed by really low lows, right? And that variability or unpredictability is something that you really want to know about. And this, goes into play for what kind of occupation you're gonna, go for, where in the city you're gonna live, and what are your options, right? If I move to Milwaukee or Chicago, there's a huge variety of experiences where if I move to a smaller town, it's pretty much the same no matter where I live in that really small town because it's all pretty rural. Considering variability is something that we really need to take into consideration. Anytime you're proposing a change, anytime you're proposing a therapy, right? The customer or the parent or the client or the patient wants to know, what are my range of possibilities? If I'm sick and I have cancer, what's this treatment going to give me? What are my probable outcomes? How can I live, or what are my survival rates? How does it vary, right? So when we look at raw data by itself, it can be really confusing. And the question is then, well, how do I summarize and make sense of different things that where I look at just central tendency or averages, things look kind of the same. So I have an example here, right? Suppose that I have 3 groups that have the same mean income: basketball players, artists, and accountants. I sample 20 people from each profession and gather data on their yearly income, and I find that it's equally the same. Now, if I'm thinking that these are my possible career paths, I might approach these and think, well, it doesn't really matter. I'm just going to go with my gut. However, if I look at the data itself, I see that there are some differences. Notably that basketball players, most of them make like nothing per year, but then there are a few really rich people. Artists, a lot of variability, not as much as in basketball players, but variability. And then accountants, same average, but very, very steady, and something that I might be a little more attracted to. Looking at the raw numbers, especially if I didn't have just 20, but I had like 1,000 of these, right? Looking at the distribution, right? Most people are down 20,000 and below for basketball. Tough to support a family with, or yourself even. But then there's just one outlier up here that pulls the average all the way up to 80,000. Artists, same kind of thing. Bunch of starving artists. Some people who have plied their trade in graphic design or marketing or something like that. And then there's the people who have made a name for themselves. And then there's the accountants, right? Different set of skills, different kind of lifestyle, much more of a 9 to 5 sort of thing. But you get this really, really consistent return where you are getting the same exact salaries regardless of who you are or what your local environment is like. So when I combine these all together, right, we can ask ourselves, how do we want to describe this? How can we represent this numerically? Because I can't put graphs in things all the time. That'd be nice. And I can really just say that, right? Accountants are really consistent, much less variability in their salary outcomes than there are for artists. And artists are more consistent or less variable than basketball players. So what we're going to talk about then are these 4 different ways to represent variability numerically. One is the range, which gives us what's the worst and the best case scenario. One is the interquartile range, realizing that outliers can be very, very unlikely. I'm going to focus more on what's kind of the middle ground likelihood of differences. And then we're going to talk about variance and standard deviation, which are a little harder to understand.